Hello, everyone. Thank you for joining us today, and thanks for bearing with us while we are starting just a couple minutes late. Welcome to the Low Energy Water Treatment Technology Challenge Information Webinar. So before we dig in, it is with gratitude and respect that I acknowledge that today I am joining from Toronto, which is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis people. I also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. So today we are going to talk about our challenge. We'll start with a bit of an introduction. We'll meet the different challenge partners, and then we'll dig into the challenge itself. We'll talk about some key dates and eligibility criteria to be aware of. We'll dig into the application process and the evaluation, and then we'll have lots of time for questions and answers. So during the course of the presentations, please feel free to use the question and answer feature of the webinar, and we will get to your questions at the end. If for some reason we don't get to your questions at the end, we will invite you to email the challenge email account, which we will share with you, and we'll make sure that we're able to follow up with you. So my name is Heather Crocheter, and I'm the Director of Innovation Challenges with Foresight Canada. And I'm pleased to be joined today by John Broglie from COSIA, Dr. Mohammed Gamal Eldin from the University of Alberta, Asfa Bekele from Imperial Oil, David Sanguinetti, who is the VP of Technology at Foresight. John, I'm going to pass it over to you.
Okay, perfect. Thanks, Heather. So yeah, I just wanted to give you an introduction of what Pathways Alliance Inc. is all about. So it consists of Canada's 6 largest oil sands producers who account for 95% of oil sands production. So the Pathways Alliance goal is to working collectively with provincial and federal governments to achieve net zero greenhouse gas emissions from oil sands operations by 2050 to help Canada meet its climate goals. And so the current plan for reducing emissions by 22 megatons of CO2 equivalent by 2030 so there's a fairly detailed plan in place to do that. So it's not hand waving. There's a very detailed, very expensive plan in place to do that, which I'll cover in a second. That's going to get us a long ways towards achieving the net zero in 2050. So the current emissions are about 68 million metric tons of CO2 equivalent. So that would be a little north of 30% reduction. So in any event, yeah, so the main I should finish that by saying that the main project, the foundational project for Pathways is a carbon capture and storage project for those 22, for most of those 22 million metric tons. So as of June of 2022, when Pathways Alliance was stood up, COSIA became the research and technology development arm of Pathways Alliance Inc. So I'm still a member of COSIA. So about COSIA, so it's made up of 4 environmental priority areas, and of course my view of all the speakers means I can't see the I can't see the slides, but that's okay. So it's the 4 areas are greenhouse gases, land, tailings, and water, and so I won't go over the emissions for the other 3 priority areas in COSIA, but I will mention that for water, we want to be world leaders in water management, producing Canadian energy with no adverse impact on water. And so over the last decade, so COSIA has been in existence for, actually we're coming up to our 11th year, but over the past decade, members have invested about $1.8 billion to develop almost 1,200 distinct technologies. Our unique IP sharing model means that use rights have been granted to all members for all of those near 1,200 contributed technologies. And so members who develop it don't give up IP ownership, but they grant free use rights to all the other members. And currently we have $31 million invested in 233 active projects.
Great, thanks, John. Now I'm going to pass it over to Dr. Mohammed Gamal Eldin to introduce himself.
Thank you, Heather. It's me, Mohammed Gamal Eldin. I'm a professor of environmental engineering at the University of Alberta, and I do research in the area of water and wastewater treatment. primarily in the last 12 years or so, I've been working with the oil sands companies through a research share program supported by them and other companies, including also NSERC, to look into ways of treating the processed water. We started in the first few years focusing on energy-intensive approaches or engineered treatment technologies. And then in the last 6 years, we've been working primarily on engineered passive systems or treatment approaches that require less energy input and so on and so forth. And I'm delighted to be part of this webinar, and I'm looking forward to discussing further issues related to this initiative and this competition with you guys. Thank you.
Great, thank you very much. And for those of you who might not be familiar with Foresight, Foresight is Canada's clean tech accelerator. We bring partners together to identify, commercialize, and adopt clean technologies needed to address today's most urgent climate challenges. We support the identification and validation of clean tech opportunities and the successful commercialization of solutions. And we do this by bringing together industry, government, academia, investors, and innovators. And there's a lot going on at Foresight, but we can divide our activities into about 5 areas. We have our accelerator programs where we support companies in different stages and sectors to accelerate their technologies. We support companies in capital attraction, and we work to help companies export. We connect stakeholders in the sector using our Helix 5 model. Again, those stakeholders being innovators, industry, investors, government, and academia. And of course, as you all know, we run innovation challenges for industry partners that want to improve their processes or reduce their environmental impact. So I am going to pass it now back to John to talk about the innovation challenge that we are here to focus on today.
Perfect. Thanks, Heather. So this challenge is a low energy water treatment technology challenge. So we're seeking innovative technologies for low energy treatment of dissolved organic compounds present in oil sands processed water. And I'm going to talk next about what oil sands processed water is. So it's water that has come into direct contact with the oil sands ore in the extraction process. So while there are other mine waters on these mine sites, the largest source by far is oil sands processed water with about 500 million meters cubed of free water in the free water zone of tailings pond. There's considerably more than that in tailings pore water, but that's pretty much locked up for geologic time once the tailings settle. So but still, it's a fairly large source of water. And part of the reason there's that much free water is because most of it is recycled. The recycle rates are typically 80 to 85%. So in spite of what you may have read to the contrary, the major ions are relatively innocuous. And the concentrations of these major ions depend on the concentrations. The connate water, that's the water that surrounds the bitumen in the ore, and so it can be salty or with lots of sodium chloride and bicarbonates, or it can have divalent cations like calcium and magnesium. And so that will at least in part determine the concentration in the OSPW. Of course, it depends on the recycle rate, the extraction and tailings treatment chemicals, and whether or not you get a site upgrader. So the total dissolved solids are typically between 1,000 to 2,500 parts per million. Alkalinity, these are fairly well buffered solutions. Alkalinity is 300 to 800 parts per million. Sodium, again, varies to a large extent because of the connate water, but 300 to 900 parts per million. And similar story with chlorides, 150 to 700 parts per million. Sulfates are 200 to 500 parts per million. And the one that we're interested in here is the dissolved organics, which range from 20 to about 70 parts per million. And so contrary to what you might have heard, trace elements and heavy metals, almost all of them meet acute guidelines for aquatic life, which is the typical requirement for a safe release of treated waters. So most meet the acute guidelines for aquatic life with the typical exception of dissolved aluminum. And so the organics, these dissolved organics, is the main source of acute toxicity to aquatic life in untreated OSPW. And so these are naphthenic acid compounds and other acid extractable dissolved organics. So I'm going to talk a tiny bit more about those because that's what we're going after here with this challenge. So I'm not going to go over this slide in any detail. There's been a ton of work characterizing these dissolved organics, but if you just look at the pie chart there, in this particular sample at least, the classic naphthenic acids would just have the carboxylic acid group, which is 2 oxygens. And so you can see in this particular sample, that's only 16% of the total sample. And so the term naphthenic acids is used generically, but it's a broad range of compounds with some of which have multiple oxygens, and also many of them have both nitrogen and or sulfur incorporated into the compound. And so so the standard method is a FTIR method, and it'll just give you the 20 to 70 parts per million of dissolved organics. But if you want to know the details of that, you need liquid chromatography and an ultra high resolution mass spec. And if you do that, which one of those that top right corner shows, is over 200,000 different compounds in those 20 to 70 parts per million dissolved organics in OSPW. So. Okay, so the challenge again is we're interested in low energy water treatment technologies that can be deployed either during active mining or in the reclamation landscape that can treat the dissolved organics so that they're not acutely toxic to aquatic life, and they can pass standard acute toxicity bioassays. And I guess maybe it goes without saying, but I will say it, the reason we want low energy water treatment technologies is I introduced Pathways Alliance as focused primarily on reducing CO2 emissions. And so what we don't want to do is solve one problem, treating water, and make another problem, CO2 emissions from the oil sands, worse. So it sort of makes sense that we want to solve the water treatment of processed water without any impact, or at least very minimal impact on CO2 emissions. And so to be clear, there's no requirement to mineralize these organic compounds, mineralize meaning to CO2 and water. We just need to render them non-toxic. And it turns out that if you leave processed water in a pit lake or other water body, toxicity is gradually reduced through microbiological processes, but that can take quite a long time, as much as 10 years for this to transpire. So we're looking for low energy treatment technologies that significantly reduce the treatment time for that. And so we have piloted a number of low energy technologies, but we're always interested in new ones that will treat these organics. And so once we've tried our fluid coke treatment, advanced oxidation catalyzed by sunlight, and treatment wetlands. And that's a tiny microcosm of all the things, for instance, that Mohammed has looked at in his research programs, but these are the ones that are getting closer to commercialization.
Perfect. Thank you, John. So now that we know about the background of the challenge and some of those main objectives, let's talk about the key dates. So we are currently accepting submissions, and you, of course, are joining the information webinar today. We are accepting submissions until February 15th. After that, the review committee will go through an evaluation that'll happen kind of mid-February to mid-March, and then we'll be letting the finalists know that they've been invited to pitch. Those pitch presentations will happen in mid-April, and we will announce the winners towards the end of April. So this challenge is open to all categories of applicants and project collaborators, including technology developers, institutions, SMEs, multinational enterprises, and research laboratories. Of course, the proposed solution must align with the challenge topic. And as John mentioned, the solutions must be low energy and significantly reduce the treatment time. As well, they must work in a northern climate. We're also looking for technology solutions that are at least a TRL level 4. So to apply, it's fairly straightforward. You'll need to register on the competition website. You can see the link there, and we'll also put up a QR code to the challenge website at the end. There you'll find the application form, so fill that out in completion, and then you will submit that and you'll receive a confirmation email. Once we receive the applications, we'll have an initial screening to ensure that they fulfill the eligibility criteria before sending them over to the review committee for their evaluation. The most promising solutions will be invited to pitch their technologies to the reviewers during a pitch session. And successful proposals will, at no cost, be able to work with Mohammed in his laboratory to test out their technology using real oil sands process water at the University of Alberta. And they may be eligible to receive funding from COSIA members to further develop and demonstrate their technology in an oil sands applications. Multiple technologies may be funded at the discretion of COSIA's members. So some tips for your application. Number one, do double check that you fulfill those eligibility requirements. Also, we strongly recommend that you don't wait until the deadline to submit your application. We are unable to accept applications after the deadline. So if there are any technical glitches or anything, you don't want to run into that issue. So definitely recommend that you get those in early. Where necessary, do provide data evidence to support qualitative descriptions. Be sure to use clear language in the technical descriptions of the technology or project and explain the work done and progress to date. Finally, keep in mind that for any challenge-related questions, you can contact us at challenges@foresightcac.com. And with that, we're going to move into the Q&A period of the webinar. So again, please feel free to drop your questions in the Q&A function. And I'm going to stop sharing for this portion. So we'll give folks a moment to digest. Yes, there will be a recording of this webinar shared via our LinkedIn or our YouTube channel, and an email will be sent out to all registrants. Okay, so we have a question. Someone is wondering, what sort of throughput are you looking for?
Yeah, so I think we would be looking at something that's capable of scale up to something like half a cube a second for treating process water. Yeah.
Someone is wondering, what kind of research service support would working with Professor Eldin provide?
Basically, by working with the winner or winners, we would provide some technical support like water quality analysis, among others, maybe some input into if we have any experience with something similar before, some advice, and things like that, right? So that's what we would provide, taking into account that the size of the unit could be housed in our labs and can be accommodated water flow wise, right? Yeah. So I would add another comment that if they have a system at different scales, maybe we can accommodate a small scale of their unit, or that can basically treat a smaller volume or something, because we only have limited capacity in terms of the feed water storage that we can provide and the flow rates and whatnot.
Thank you. Someone is wondering if there's any funding provided to the winners.
I can answer this one. So there will be some funding provided for the winners. It's limited funding though. It's provided through a grant we have received, but that's not going to be the end of it. There could be additional funding provided by COSIA members if there is really high potential, but also there is some leverage funds available from industrial research share. That's why I said we can provide some analysis, technical support, and things like that. Water quality analysis, and technical support.
But to be clear, it's support from Mohammed's research facilities.
Yeah.
Not a cash. It's in kind. Basically, Mohammed and his team testing the technology and doing some advanced analytical work to see what the effect of that treatment technologies are.
Great. We have a question around IP. Who owns the IP if there is new IP? And if there is already IP for a technology, what role does COSIA play here?
Okay, so if there is IP that's already owned by the technology proposer, then you would clearly keep that IP. Mohammed is there to test it and provide information to COSIA members that confirms the potential effectiveness of the technology at treating these dissolved organics. And then after that, if it gets scaled up to, say, a field pilot, then that's a negotiation between whoever's hosting the field pilot. It's going to be one of the operating companies. So that's, Imperial, who Asphalt works for, or Syncrude, or Suncor, or Canadian Natural. And so you would be negotiating that with whoever's doing that scale up.
Thank you. So we have a question around the pilot. So if the pilot study goes as intended, are there opportunities to become integrated and start working with oil and gas operators?
John, I can
Yeah,
comment
go ahead.
on this one.
Thanks,
Right?
Aswal.
Yeah. So, I mean, because this is a priority for Imperial and the other COSIA members, essentially it would be, if that is validated, would be taking it to the field. Exactly.
Great. Thank you.
Yeah, Heather, one question I was going to also, respond to is about somebody was asking that, what a tier for TRL for readiness means. I think we're following a standard tier definition. I think tier 4 stands for, I think, validation at the lab scale, the minimum, right? So, but that doesn't mean, of course, if somebody has a higher level, that would welcome that one as well.
Great, thank you. So if the focus of the challenge is toxicity, what kind of analyses does Dr. Eldin's lab provide? Will these include standard aquatic toxicity tests?
The answer is no. We would basically probably analyze for naphthenic acids, classical naphthenic acids, and if most of them are removed, or at a level that's acceptable to us, maybe there could be a potential for doing few toxicity tests, like one of these standard ones, but I don't do them in my lab. We do other things like typical ones, microtox, other, bioaccumulation, or simulated bioaccumulation tests, SPME and things like that, but we don't do the Environment Canada approved tests. No.
Yeah, I think part of the reason for that is, in an event scale test like this, there isn't enough water to do, say, a 96-hour trout test. You just don't have enough water. I mean, Mohammed, I think you've typically done microtox, but we also have a great method for the toxicity of the organic compounds that Imperial Oil has led on behalf of COSIA members, which is a BESPME method, and that we've got a good correlation between the results of that very simple test and the toxicity related to the organic compounds. And so we can definitely infer the toxicity with these other tests, but you just can't do most of the standard tests without lots of water. So, and
there is another also collaborator with us who has developed through the work with my lab and the COSIA members, great, like cell line, like acute toxicity tests that we could also have, access to, depending on, how great the results would be and so on. Yeah.
Great. So we have a question, is there a data sheet with the technical requirements, description of the organics, concentrations, and so on? So I'll recommend, and I'll put the link in the chat to the challenge website where folks can download the program guide. If there's more information required, feel free to shoot us an email and we can get you some of those resources. So I'll just post that there. Okay. Is there a limit to the value, or is there a list of the limit values for the substances that may be in the water and that can be released in the environment?
Are you referring to the dissolved organic compounds? So if that's the question, then there actually isn't. So for naphthenic acids, which are not uncommon to see in wastewater from upgraders and refineries, there is no limit for those right now. And so some of that work is ongoing with both the province and the feds. But certainly the key thing is, like in all cases, it would have to pass the acute toxicity tests. But yeah, so there isn't a number per se for the dissolved organics other than not acutely toxic.
Thank you. In terms of energy utilization, is flare gas an option in the region where the pilot would be performed?
Asfa, you want to try that one?
Maybe this is one of those questions we could get back to.
Yeah.
I'm not close to that option, to be honest. But we can, consult our friends, my colleagues, and provide a response.
Okay, fantastic. Question for Mohammed: in your current work with wetlands, have you found good success, and are the salt levels a limiting factor or a problem for wetland plants?
We have done some initial work related to maybe applications in wetlands, and actually SFAO can jump in as well. But there are some plants that could be more tolerable towards high TDS levels in the water compared to other plants. And I think, yeah, there could be some success with wetland applications, and we've seen some success already, and SFAO can probably elaborate furthermore.
Right. So at Imperial, we have a pilot treatment wetland that we've been testing for the last 6-7 years. But fortunately, the water we have so far have low salinity, so we haven't actually seen much of an impact, because we're talking about low TDS, it's around 1,000 ppm. But in general, I think, at least looking at the literature, notwithstanding what Mohammed said, in general, salinity can be an issue unless one is working with the more salt-tolerant plants.
Great, thank you. So we have a question around current collaborators. Are they eligible?
Actually, it was specific if it's a person who collaborates with me currently. I don't know who that is, but I wouldn't answer that question. There is a conflict of interest here, but I'll leave maybe John or Asfal to answer this.
I mean, my take on it is that we're really looking for the technology that solves the problem first, and everything else comes next, in my opinion.
Yeah, and I would just add to that during the review process, if there are any conflicts of interest, we can manage that with the review. Maybe Mohammed would excuse himself from reviewing that application. So that's something that can be managed around. Great. Okay. Can they perform their own biogeochemical and toxicological testing?
Yeah, I mean, I don't see why not. I mean, what we're offering here with this challenge is, the extensive test facilities and analytical equipment that Mohammed has in his lab. But if you want to do your own, that's fine too. Sure.
Great. Thank you. Is it possible to get wastewater for tests?
John, I can
sure, yeah.
Respond to this one. I mean, this again depends. If we're talking about just this specific challenge, that is something that would come after that. But in terms of collaborating outside this challenge, usually, yeah, as an industry rep here, we want to still know what the water is going to be used for. So.
Yeah. But I mean, Mohammed has a stock of processed water in his lab in a very large walk-in refrigerated storage. And so it's part of the reason why it's very easy to do this testing in his lab is he's got everything set up to facilitate that.
I can add something as well.
Yeah.
So if, let's say it's related to the, like a winner of a technology and we're doing some testing, let's say we analyze for the naphthenic acids in my labs, and these waters, acids could be for, we can send them for you wherever you want to get the toxicity done, as long as it's coupled with the water quality analysis to make sure we're accurate with what we're testing. But again, I have a large volume in my labs, but I cannot also treat in my labs a huge volume that could be sent also. Half of it could be sent for toxicity analysis. Like, let's say that if the facility really is big, that's something we need to discuss in the group when we evaluate, applications that maybe some work could be done in another facility where we have access to that could be housed outside or something. But that's something we need to wait for, right? Yeah.
Great, thank you. Someone asks, earlier in the talk, you mentioned a number of front runner solutions closer to commercialization, examples, pet coke, wetlands, et cetera. What are the major gaps in those approaches that the new technologies through this competition should aim to overcome?
Yeah, I mean, I can start with that if you like. Although I did notice, back to the limit values for substances, what I didn't mention is that there isn't actually a good correlation between the concentration of these dissolved organics and the toxicity. There's a general correlation, but you will see, say, 35 parts per million of naphthenic acids using FTIR that's non-toxic and 20 that is. And so part of the reason why there isn't a limit for those compounds is there's 200,000 of them or more, and there isn't a good dose response to that, which is why the whole effluent toxicity test or this BESPME test is effective. But in any event, it's probably best if some of the other operators talk about the technologies that they're commercializing. But I will just say, for instance, that the pet coke technology that has been had a very large field pilot this past summer by Syncrude. I mean, the reason it's a very, very cost-effective, low-energy treatment system for Syncrude is because their upgrader makes fluid coke, and so it's the size of very fine sand particles. And so while it doesn't have much surface area compared to, say, commercial granular activated carbon, they got a lot of it, and so they have more than enough of it of this fluid coke to treat the volume of processed water that they would like to treat for safe release to the environment. All the other operators either don't have an upgrader on site or have delayed cokers, and the delayed cokers, of course, the coke comes out in big chunks, so it has zero surface area, and you'd have to grind it up and activate it, which is a possibility, but it's expensive. It requires energy to produce, activated coke from delayed pet coke. So that would be an example of, pet coke is for fluid coke Syncrude has likely a great solution for them for the most part. It's not a good solution necessarily for the other operators. Asfad, do you want to?
Yeah, no, that was a good one. And then, as an example, wetlands, I mentioned earlier, we have a pilot wetland. In general, one can say they work, but of course we have to operate it within that narrow window of the year, during the growing season. Scale up is probably be required. So yeah, I think we want to have more options in the toolbox.
Great. Is there a body of water source that can be pumped through our technology and samples before and after they're taken and then taken to your lab and processed?
Well, I mean, I think the whole point of this challenge is to do a small scale test, which is again why Mohammed is directly involved. And so the nature of the question makes me think that you want to put a test rig on site and pump water from say a source, a processed water source on site, and that's really not what's contemplated with this challenge. It's really meant to be the bench scale testing. I don't know, maybe I'm misunderstanding the question.
If the person who asked the question is able to provide, correct. Is it portable, and is it portable and takes a couple of hours to set up? It is portable and takes a couple of hours to set up.
Can I suggest something? If let's say when we review the technologies, if the scale is not humongous, not big, it could be set up in my lab. Great, we can accommodate that. But if it's going to require more volume, bigger tank, because for example, I cannot just store in my lab, like 2 cubic meters of water in my lab. It has to go to a special place and divide it into small pails and whatnot. But if there's something that really is promising, maybe we can discuss. But it could be set up somewhere else, not in Fort Mac, but somewhere else where we can have access to and could be tested there. There could be something there, but I think it's a possibility if John and Asfel agree.
So maybe something to explore down the line. Great, thanks. Is there a list of the technologies that have already been tested somewhere?
Well, I have a great answer to that. So we go to some trouble each year to produce a research summary that's typically about the total documents about 100 pages, sometimes a bit more. And it lists all of the active projects we have in the water area of COSIA. And it has depending on the size of the project, anywhere from a 2 to 6 or 7 page summary of what's being tested and what are the results to date. And so those are all available on the COSIA website. If you need any more information, if you go there and you're still looking for something, you can certainly contact myself or Asfal, and we can we could potentially get you more information. But the best place to start, I think, are those research summaries, because they've got a pretty compact description of the work that's going on.
Great. Thanks, John. And so that is wrapping up the questions that are outstanding. We'll give folks maybe just another minute in case any other questions come up. And while we're waiting for that, I'll share my screen again so you can see the QR code for the challenge website and also the email address for our challenge program. So if you think of another question that you don't get a chance to ask today, no problem. You can send us an email. You can download the program guide from this website, and we will make sure that you get all the information that you need to submit. Our contact email is available for the panel. Aaron, maybe send me an email and I can put you in touch with the panelists that you need to connect with. Last call for questions. Okay, maybe we'll leave it there. Thank you so much to everyone who joined today and who asked an insightful question. Thanks to our panelists for your wonderful presentations and insightful answers. And we are very much looking forward to seeing all the submissions to this challenge. So thank you so much.